Hello again, folks, in 113. Today we're going to be covering the last section for this group, section 10.1. Here's a quick look at the calendar. Today is Thursday, let's see, September 16th, so appropriately we'll have this last section. If you're worried about the test, don't be. All right, I'm going to tell you the specifics of that afterward. Okay, but we're going to be doing 10.1. The packet that I have for you today consists of these pages. First of all, an overview, and I'm going to explain this, of how to convert between percentages and decimals and fractions and so forth. Right? I've meant to try to summarize this, and if it isn't intuitive, I promise I'm going to go into it. Okay. Other than that, I swiped this. If you're not content with my explanation, I stole these from your textbook and tried to put them all on one page. These are the same procedures, but just explained more or less verbal rather than pictorial. All right. These formulas will be useful. All right. They're really the same formula, they're just labeled differently. If you notice, they consist of subtracting and then dividing and then multiplying. Well, that's the same thing here, right? Except for a different purpose. Okay. Then, of course, there are the actual examples. I left the solutions just in case you don't get to see this video. All right, you could explain it. It's self-explanatory. All right, so don't worry. All right, we'll go through these, and I think that's it. Yes. All right. Yeah. All right. Good. So if you're following along, do print this out. You can annotate if necessary. Actually, what I should do is dig up another diagram that I have here, which I will. And turn on my projector and also adjust the lights again. That's going to require moving. Okay. That's not too bad. I really should put like a tape on the floor here so that I have an inkling as to where this is supposed to be. I don't see it. Well, I have to keep, because I'm in my house, so I have to keep moving things. It's like living in a slide puzzle, basically. Alright, the keystone is a little too loose on this device. It's manual rather than digital. Alright, I think that's sufficient. Alright, here's our page for the previous and forthcoming PDF files if you're inclined to print these. There was one thing I'm trying to swipe from here. Let's see. I had given you these two diagrams. There's no point in making them part of this packet because they were from previous packets, but I think I want to refer to them, so I'm just kind of downloading here. Okay, that's one. And there's the other. Let's see if they put them there. Now it went to a different location. That's stupid. I hate that. There we go. Enough of that. Alright, now what we had been, the royal we, had been discussing previously was essentially the concept of fractions, but without really being explicit about it. Right? Remember, a fraction, as anyone knows, is this idea of having some numbers sitting on top of another number. The more general way of referring to this idea And that seems a little bit dim, so let's see if we can brighten that. The more general way of referring to that idea, that's the thought balloon, of a number sitting on another number is ratio, actually, right? Because it's less strict. It could be any type of number sitting up here, any type of number sitting down here. All right, it's more or less referring to this idea of one thing divided by the other. All right. In context, you might see these sort of signal phrases in English. So if you see A per B, for sure, you're dealing with a ratio of some sort. All right. We call it a rate instead if there are different types of units, and the operative term there is different types phrase. Because even if they measure length, say for example, in superficially different units, like say centimeters or inches, those are still measuring the same physical thing. What I'm getting at is that a more appropriate situation would be something that measures a distance and then a totally different physical concept, say time. All right. So this is going to be more important really in section 114, the second semester of this class, but kind of save it in the back of your head. All right. Anyhow, we're going to be dealing with just fractions, all right, which are a slightly more specific incarnation of a ratio, all right? Why do I say that? Because they generally do not have units, right? So you don't see inches, centimeters, or anything like that adjacent to a number, all right? When we refer to the top, we call it a numerator, and when we refer to the bottom, we call it a denominator, all right? And there is no decimal to be seen anywhere in the figure, all right? Now, having said that, what you'll be asked to do is probably convert from a fraction to a decimal, which is why it is now an appropriate segue in the conversation. All right. This diagram, I tried to summarize what the basic procedures are. All right. So you see three styles of a number, if you will. All right, a percentage, a fraction, and a decimal, respectively. All right. Sorry, I'm using the abbreviations just for the simplicity, but frac is fraction and deci is decimal. So something with a point, something with a fraction line, and something with a decimal symbol. All right. So you will see something and then this symbol, percent. All right. You'll see something, point something at minimum, you know, or even just point a number, all right? And in this instance, you'll see something sitting on top of something else, all right? This is all how this would look. Here's the all-seeing eye, all right? Now, basically identify what you're starting with, all right, and then where you want to go to. So if you're starting with a fraction, say, and you wanted to convert to a decimal, really is just a simple process of dividing the top thing. See this purple line? There's a dot to represent the starting point here, and an arrowhead to represent where you're headed. So if you're starting from a fraction, you're going to a decimal, you're going to divide the top thing by the bottom thing. That's just as plain as saying, as you can get, right? Numerator divided by denominator, all right? So if you had, say, something like 1/2, all right, you would, in the old-fashioned way of doing it, which is very useful, it's a better mental exercise. Draw a division box appropriately next to your fraction. All right, drop the top thing on the inside and throw some zeros in there to get rolling. All right, and then you would divide more or less brute force. All right, so you would say, how many 2's can you fit into 1? 0. But how many 2's can you fit into 10? All right, exactly 5. And it would terminate at that point, because you would subtract these and you get 0, and these are superfluous. So you'd have a fraction in the style of a decimal known as 0.5. There are other ways to go about it, and maybe more elegant, but this works 100% of the time. All right, top divide by bottom. All right, if on the other hand, all right, you were converting from a fraction to a percentage, all right, what does that entail doing? Notice the point, all right, and the arrowhead, all right. You're going from here to here, you're going to multiply by 100. All right, I try to make it as intuitive as possible. So if you had, pardon me, the same fraction, 1/2 times 100, right? Remember, when you multiply fractions, right, you can always disguise a whole number, as in the case of 100, as a fraction by throwing a 1 under it. So make a line and then a 1, and it's all legit. Then the most brute force way of doing this would be top times top, and you would get 100, and bottom times bottom, and you would get 2. And then if it's possible to simplify this, all right, and it is, divide the top by the bottom, and you would get a 50, right? Now, because you're multiplying a fraction times a percentage, it would be 50%. So you would see that these three styles of a number, 1/2, 0.5, and 50%, are all really the same thing. They're just in a different presentation. Right? And you could go back and forth. Now, if you wanted to go the opposite way, say from percentages to fractions, you would divide by 100. Right? If you wanted to go the opposite of taking a decimal to a fraction, you would consider the place value and make that your denominator. All right? Remember, place values is another thing that is very important, so I might as well resurrect that. All right. From earlier, I gave you this thing that I swiped from the textbook as well, because it's a nice outline. This page. You definitely want to know your place values. As a teacher, you should never take for granted that your students know anything of what you're talking about, right? You'd like to, but it isn't, in the long run, it isn't practical. So remember, place values is this stuff. This is a very good summary, right? Here's your decimal point. Things to the left are whole numbers, ones, tens, hundreds, and so forth. In New Jersey, they kind of have the expectation that you know up to at least 1 million, right? Why? So you can play the lottery, I guess, right? Wouldn't it be great, to win that? All right, on the flip side here, the right side, it's similar things, but they have the suffix THS, right? So 10th place, 100th place, 1000th place, 10,000th place, 100,000ths, and millions. All right. Notice that there's no 1th place. It's really the sort of symmetry is here and here, right? Tens, tenths, hundreds, hundredths. Right. If you had the figure that we were working with, all right, 0.5. Right, this is again naturally a decimal, and you wanted to go backward to it being in the presentation of a fraction. All right, really it's just a matter of identifying where the far right digit is sitting. So look for the far right digit's place. All right, now in this case there's a 5 here. And that is sitting one place past the decimal, so it's the 10th place, right? You could reasonably then write the denominator as tenths, but the THS is, again, superfluous. You don't need to spell anything out if you're using numerical symbols, right? And then just take what's there, all right? If you see a 0.5, you could just simply write 5/10, all right? If you had, just hypothetically, a 1.5, say something like this instead, then just take it as 15 instead, right? Yes, that's an improper fraction, but it's totally legit. The one thing that you have to dismiss is the actual decimal point. Why? Because the whole point of the exercise is to convert from a decimal to something that doesn't look like one. So from a decimal to a fraction. So take all of the digits, all right, more or less delete the point. Right, and then you have it. And what you would do is you would simplify. So whittle this down as best that you can. All right, without trying to scribble onto this. If you had 5/10, the original figure, all right, remember rules of divisibility, all right? you might have some inkling about that, right? These are both made of the number 5. These are factors. So you can simplify these by dividing by 5, right? And you would end up with exactly what we started with, which was 1/2. Right? To take the additional thing, example, 15 over 10, right? They're still divisible by 5. So you could keep them in the style of an improper fraction where they have either equal numerator to denominator, so it would be 10 over 10 technically, or something larger normally. 15 divided by 15 would reduce this to 3, and 10 divided by 15 would reduce this to 2, all right? And in terms of an improper fraction, that's in simplest form. Believe it or not, in upper level math, it is favored writing things in the improper style rather than the mixed number style, all right? I know that in ordinary conversation, so you went to the store, like Home Depot, and you said, hey, I want 3/2 of a nail in terms of its length, and they would scratch their head and go, why are you talking like an alien? But in math, this is actually more practical, believe it or not. Now, to make it more human, right, you would go the whole 9 yards, right? And at this point, do what we had done earlier, which is to convert this to maybe a whole number. 1, it would definitely have to be. And then whatever the fraction is. How many 2's can you squeeze into 3? 1, right? And 1 left over, so 1/2. Okay. This is again an overview. We'll go into specifics as we go through the semester and today. Let's see. When you are converting I have to sort of condition myself not to use blue, even though I want to, because it doesn't erase very well. When you're converting from a decimal to a percentage, because you're going to a percent, as before, going from something to a percent, you would still be multiplying by 100, all right? Realize the effect of that, though, all right? If you had this, here's your decimal, 0.05, and you were converting to a percentage, right? And you multiplied by 100, you could, of course, do this brute force, write this out, as you would, sort of vertically, and systematically do the work of going, okay, 5 times 0 is 0, 5 times 0 is 0, and 5 times 1 is 5, and then take into consideration how many decimal points you have to account for, and then from here, move over 1 decimal point, and you would end up with 50%, or use a mental math shortcut, which basically says that if you're multiplying by powers of 10, right, move right. The number of decimal places. Pardon me, the number of zeros. I'm spelling zeros with an ES, and you could, or just an S. Zeros. Alright, so what does that mean? It means that if you have a power of 10, as in the case of 100, 1,000 would also be a power of 10. 10,000 is the power of 10, you know? So 10 to the 0 is 1, 10 to the first is 10, 10 to the second, as in this example, is 100, 10 to the third is 1,000, and so forth. The number of zeros that you see correlates to the exponent, right? So if you have a figure like this, 0.5 times 100, that's 2 zeros, therefore you're going to move to the right that number of spaces. So from here, 1, 2, all right, and fill in the void with a 0, hence 50. Just remember, don't forget, as an afterthought, because you're converting it to a percentage, to write the symbol. A lot of times I forget to do that myself. Okay? Now, if you're going back the other way, it is just the same thing. If you're starting with a percentage and you're going either this way or going either this way, you're dividing by 100, right? And in that case, %50 is basically asking you to do this. Taking 50, and this means literally divide by 100. And the decimal point would technically be here to begin with. You could either write it in the more or less traditional way, which is the colon with the line through it, or you could write it like this: division of 100. The bar is the same as the colon with the line through it. Right? It means divide, just as this means divide. Right? I know a lot of times people don't feel comfortable doing that, but at least in the United States, right, around this area. Right? But that is correct. Right? Then what do you have? You have a fraction. Right? Still not quite what they want. They want a decimal. They, who's they? My imaginary friend. All right. And you could then pull tricks. Right? You could either do the brute force division of 100 sitting here and 50 sitting here with some zeros thrown into it, and say to yourself, well, 100 will not fit into 5, it will not fit into 50, decimal zero would be there, the points line up, but 100 would fit into 500 exactly 5 times, in which case it would terminate, and these would be unnecessary, and then you get 0.5 again. Right? Or there's lots of little tricks, right? You might just recognize, well, if it's 50 over 100, it's already a 50 sitting in the hundredths place, right? That would be more efficient. That's 50 in the hundredths place, or up to the hundredths place, so it will be 0.50, right? You could either write it like that, or you could write it like this. Just to say 0.5. How come? Because it would also simplify to 5/10, their equivalents. And if you went even further, you could simplify 5 over 10. How so? Divide each by 5 and you would get a half. Right? The essence of this lesson is that these are just merely 3 styles of the same number. Right? They don't look the same, right? But they represent the same quantity. Right? All right. Let's do some examples. I'll take a sip of coffee. All right. Let me pull up my bootleg paint again, and we'll go through these. And keep this on hand, right? Again, if you feel inclined to annotate, right, my own instructions. My teeth are bothering me. Okay. All right. Change each of the following fractions to a percentage. All right. Again, you could do this, the actual process of dividing, pardon me. All right. When you go from a percent to a fraction, right, you are dividing. Right. So just to refer to this without switching the slide, right? Percent to decimal or percent to fraction, you're dividing. Right. So you could do the actual division if you want, but if it happens to already be sitting over 100, this already means that symbol. Right. So you could save yourself a little bit of trouble in that example and just simply say, well, it's 67%. All right. In the case of something like this, right, where you have a denominator of 20, all right, there's a go around, right, which is you can upgrade sometimes, I can't really emphasize that enough, sometimes, this doesn't work 100% of the times, to a denominator of 100. So what I'm getting at is that if you see that you have numbers that are divisible, and that is something that you would recognize with a lot of experience doing this, 20 can be upgraded to 100, right, fairly easily, right? Why? Because the relationship between 2 and 10 is the same as the relationship of 20 to 100. Now the question is, what would you have to multiply by, right? As I am fond of saying, and I will say many, many times, right? You can get away with murder in math world as long as you're consistent. So once you've decided what it is that you would technically have to multiply to accomplish this, just make sure you do the exact same thing to the top and everything is fair and square. All right. So the relationship of 2 to 10 is via times 5. All right. So if you're going to multiply by 5 to upgrade, all right, then do the same thing to the top, and that's all legal then. So 11 times 5 is just simply 55. And then again, if it's already sitting on top of 100, then that means that this is really 55%. All right. Now in the case of 15 over 16, you can't actually do that, right? Why? Because the number 16, no matter what you multiply in terms of a whole number, is not going to produce 100. You get some kind of decimal or some whole number that is just shy of 100 or overshooting it. All right. In that case, you pretty much are stuck with doing the traditional division, which is to take this 16, leave it on the outside as a divisor, and then insert 15 inside a division box. All right. Yes, you could use your calculator and divide 15 by 16. That is, you press 15 first and you hit the division symbol and then type in or enter 16 second. But do not try to circumvent the actual mental exercise, because you're doing yourself and whoever student that you're trying to teach a disservice. All right, they need the experience. It's sort of like going to the gym and not using the equipment. All right. Anyhow, 16 goes into 15, or is it too small? It would be too small, so we're just going to fill the void with a 0. Remember, the decimal points line up. All right. 16 goes into 150. You can probably guess, right? If it was times 10, it would be 160, and that'd be too much. So you can estimate. Try 16 times 9. Might be a little too much or too little. Let's see. 6 times 9 is 54. Carry the 5. 9 times 1 is 9 plus 5 is 144. That's probably as close as you're going to get, all right, without overshooting it. So 9 sits above the 0, all right, and then you would subtract 144, right? That becomes a 10. This becomes a 4. 10 minus 4 is 6, and 4 minus 4 is 0. You can put a 0 here and a 0 here, or leave them out, all right? And then you bring down another 0, and you continue, all right? 16 goes into 60 again, estimate, all right? 16 times 3 would be 48. That's probably as close as you're gonna get, all right? If you did 16 times 4, carry the 2, it would be 64, that's too much, all right? Don't ever feel bad if when you're doing your scratch work, you end up doing more than is actually necessary, because a lot of times, especially if you're doing this by hand, you may end up coming back to the thing that you've already calculated, all right? Anyhow, so this is 48, these are unnecessary, and you subtract again, all right? Borrow, that becomes a 5, and this is now 10. 10 minus 8 is 2, 5 minus 1, 5 minus 4 is 1, so you have 12, all right? I have to remember to put the 4 here, all right? And then bring down a 0 again, all right? And reason to yourself, well, if it's times 9, it's 144. Let's try 16 times 8. 48. Carry the 4. Alright. 16, pardon me, 8 times 1 is 8, plus 1 is 128. That's too much, so it would have to be times 7. 42. And that would be 112. So you have 7. And that's now going to be subtracted. And you may end up needing another 0 here eventually, so just throw that in. Do the work. This is borrowing, so it's 1, and that's now 10. 10 minus 2 is 8. And I believe you just have to do this one more time, so you have 80. Good. 16, let's see, times 4 is 64, right? Times 5 is 80 exactly. Very good. All right. Very good. All right. Now, again, don't ever feel bad about doing any of this scratch work. I would never do long division in my head. All right. What you're doing is you are strategically building up a frame of reference, right? A frame of reference that you would not have otherwise. All right. So what do you end up with? A 5, and that's that. This is the decimal, though, right? You have converted, in this instance, a fraction, all right, to a decimal. All right. Now, if you're going to convert a decimal to a percentage, right, dividing the top by the bottom, right, you have to do one more thing. You have to multiply by 100. Right? So, if you multiply by 100, what is the effect? The decimal point would end up scooting over 2 spaces, which means that you would be left with, eventually, 94.75%. This is brute force, but it works 100% of the time. Now, I'm going to show you an alternative way of doing this particular example, all right? And then you could decide if you feel more comfortable doing it this way, the way that it works 100% of the time, which is more tedious, all right? Or maybe explore the option of fractions. The only reason I didn't start with that is because, you know, sometimes people don't like it, all right? So, here's an alternative, right? What I did was basically this for this last problem. I took the fraction and I converted it to a decimal first, because then I knew that multiplying by 100 would just involve scooting a decimal over. So I divided the top by the bottom arrow, and then I multiplied by 100 to get to here. This is an indirect path to get to this point, though. If I wanted to go from a fraction to a percentage, what would I have to do really? All right, multiply by 100 directly. All right, let's see what happens when I do that. Uh-oh, I want to sleep. Sorry. Okay. Let's remove some gobbledygook. We already know what the answer is, right? 94.75. Oh, I invented a problem. No, that's correct. Give me 1 minute, I'm sorry. Oh, yeah. Forgive me. I seem to have jumped the gun a little bit here. So, humor me. I'm off by 1 digit. This is indeed 9. And this is indeed 144. 6. I didn't lift this a lot. I think I did it right. Not seeing. I'm sorry, bear with me 1 second because I gotta make sure that I don't mislead you. Oh. Because I borrow from here, it's not 160, it's just 60. Sorry, see. That was sloppy. Bad handwriting, alright? If I can't take advantage of the situation to impress upon you the importance of not doing this sloppily, doing this on graph paper, writing it with neat handwriting, then I'm missing the opportunity, frankly. Anyhow, so that's just 60, which means what? It means 16 times 3 is 48. This is a 3 here, not a 4. I somehow miffed that. Alright, difference is 2. And then you have 12. And 120. 16 times 7, 42, 412. Alright, I'm running out of space, unfortunately. I should be doing this on graph paper for the reason I mentioned, namely neatness. And that's 8. And then you have the extra 0. And that is 16 times 4. 64. 16 times 5. 80. Sorry. Alright. 0. Alright. So, time is 100. The effect is to make this 93.75. Now, percentage. That's correct. I had, what is it, 94.75? That's because when I had 5 minus 4, I put the 1 here rather than recognize I borrowed. So it would have been 0, not 1. 60. It would have been just 60. Then 160. Alright. Anyhow, let's do it the more strategic way, perhaps, which is to do it directly rather than indirectly, otherwise you can see you make mistakes like moi. Alright, let's go directly from a fraction to a percentage rather than go the indirect path. So I'm just going to multiply by 100. So if I start with 15 over 16 and I multiply by 100%, technically, stick a 1 under it, alright. Then you could do it brute force, which is to do top times top, and you would get 1500, alright, and then do 16 times 1 and get 16, right, and then divide as an afterthought, right, to get the decimal equivalent, because you'd have a fraction that is indeed a percentage, but this is not good presentation, right? Right. The more strategic thing would be to try to simplify first, right, so that you don't have to work with such large figures, and as you can see, it's easy to make a mistake. So I know from experience that 16 is made of the factor of 4, and 100 is for sure made of the factor of 4, so I can definitely simplify with that. That means that if I had 15 over 16, and I'm multiplying by 100, that 16 divided by 4 would be 4, and this would be 25, right? A little bit easier to work with, maybe, all right? They're kind of crummy numbers no matter what you do. Alright. If you did 15 times 25, alright, part of this would be 10, alright. 10 would be 250, alright. The balance of it would be another 5, which would be 125, alright. So that would be 375, I want to say. And that would be 4 times 1, which would be 4, alright. Still have to simplify this, but it should be equivalent to that, alright. I'm just going to check. Yeah, I'll cheat just for this moment here, for the sake of timeliness. Yes, okay. So 375. If you use this incarnation of the solution, the outcome I should say, and well, this one is fine, alright? They're equivalent, but one has slightly smaller numbers, so I'll use this one here. I'd still end up getting stuck doing this, which is divide the top thing by the bottom thing. 4 does not fit into 3. 4 fits into 37 roughly 9 times, which is 36, and the difference is 1. 4 goes into 15 roughly 3 times, which is 12, and the difference is 3. The decimal point is here, so it would have to align up. Alright, throw in a 0 and continue until it terminates, alright, or if it repeats potentially. 4 goes into 30 roughly 7 times, which is 28. And the difference is 2, 1 more 0. 4 goes into 20 exactly 5 times. Alright, and there you have it, 93.75, but it is already a percentage. It's already a percentage because you already multiplied by 100. Right? If you use this figure, alright, it's a little outside the realm of the familiar. So you're kind of in the same scenario as before. You'd be starting with something like this. And you'd say, well, 16 is not, it's not going to fit in 1 or 15, but it would fit into 150. 9 times, we've firmly established that at this point. Right? Just don't make the boo-boo that I had done before, which is when I borrowed to make this 10 and neglected to change this to a 4. Right? 10 minus 4 is still 6. 4 minus itself is 0. Could you put the zeros here? If you want to, you're welcome to. Alright, drag this down, it's realistically 60, alright, 16 goes into 60 how many times? 3, which is 48, the difference is 12, drag down to 0, 16 times 7 is 112, the difference is 8, drag down to 0, 16 goes into this 5 times, which is 75, and it terminates. The problem with this is that you have slightly less familiar multiples to deal with, multiples of 16, alright? I had said a while back, again I'm going to take advantage of the situation, stressing the importance of memorizing your multiplication tables. This is the kind of thing that gets glossed over sadly nowadays. I'm trying to find it in my packet. No, it's that old one. Sorry. Yeah. This is from a previous packet. Multiplication tables. In the old days, what you were taught is to memorize up to from 1 times 1 to 12 times 12. Pretty much this entire table. All right, from in the United States at least, from about age 8 forward. All right, why? Because it makes you, when you have something memorized, it makes you a little bit more strategic, all right? Why did I make a mistake earlier? all right, because 16 is not something that is familiar, all right. I have a method for figuring it out without using a calculator, you can see, all right, but it's adding to the tedium of doing it, all right. Anyhow, the other thing is neatness, all right, simple neatness. I made a mistake, the bottom line before, because I had sloppy handwriting, all right. Now imagine a little kid who's in maybe, you know, 3rd, 4th, 5th grade, something like that. Do they have the best handwriting? Not all the time, and I think less and less so nowadays because we're inclined not to write much of anything, and we should write things. Give a kid adequate space to work, right? Give them some kind of scaffolding, all right? I say graph paper, all right? Again, I don't mean to beat a dead horse, but you can see where there's issues, even for an adult. So, that's that. When you taught your numbers in the United States, how to write the alphabet, what do they give you? They give you special paper that looks like this, right? At least traditionally, right? It's sort of a loose leaf paper, right? And they say, all right, kid, when you make your A's, right, you go up to the solid line, and the middle is the dash line. When you have a lowercase, you go only so far as the dash line, right? We do that for writing, right? But when it comes to math, we have nothing to give a child. We shrug, and we go, oh, okay, kid, here, scribble something onto a piece of paper. Having a nice clean surface is nice, as you can see, right? But my argument is, you'd be less likely to make a sloppy mistake like that, all right? If you give them some kind of structure, right? And when it comes to something that is numerical or mathematical, the grid pattern is what is helpful, right? Right. So if you had something like even something as simple as this, 16 times 5, right? And you distribute the 5 as you would here and here, you have nice, neat columns to write. Right, this is 30, carry the 3, and that's 80, right? And that's the tip of the iceberg. If you had a second digit, right, to fill in the voids here and here, you have to make sure that you align things. Neatness helps avoid mistake, right? Handwriting is very important. People don't treat them as though it is anymore, but it is. It's very important. But I digress, right? So you have that. Enough belaboring point. And we'll continue. All right, let's say you're going from a decimal to a percentage. We'll do this more quickly now. As a teacher, you will find that you will make mistakes in front of your students regularly, and they will be merciless. If you're like, who hired this damn fool, you know? Be prepared for that. Never take yourself too seriously. Right? Anyhow, change each of the following decimal numbers to a percentage. Right? I'm gonna again go through this process. Right? All right. I'm gonna start with a decimal now and go directly to a percent. All right. If you have to travel from a decimal to a percentage, remember you're multiplying by 100. Right? What is the effect? Move the decimal point twice. Which direction? Right. Right? So, times 100, 1, 2. That means you end up with 14% in this case. Times 100, move the decimal place twice, 1, 2, 89.3%. Times 100, 2 spaces, 1, 2, 76.25%. Okay, that's pretty quick. There's no problem. I'm just debating showing you something. That last bunch, I'm probably going to regret this, but I'm going to do it anyway. The last bunch, as I mentioned from before, it's bothering me because I don't feel that the presentation is enough. All right. I got to the answers exactly as I wanted to. All right. That's already a percent. This one, I upgraded over to 100. All right. And I got to the answer exactly as I wanted. But it's only the last example, which I'm being a nut about. I got to the answer after a lot of tedium, right? The process for doing these, just as the process for doing these, is the same, right? If you're multiplying by 100, this is the result. If you're multiplying by 100, this is the result. If you're multiplying by 100, this is a result. The repetition is important. All right. Watch what would happen if you did this in a slightly different way. Rather than employing mental math, which is maybe not the first thing you should go for. All right. Look what would happen. You can convert to something that isn't a percent to something that is, all right, and is the same process. Whatever you start with, fraction or decimal, when you're going to a percent, you're multiplying by 100 ultimately. All right, that's what we just did for the actual decimal numbers. It's the same thing, but it's kind of disguised. That's why I'm, sort of having inner conflict here. Right. You could just recognize, as I had encouraged you initially, to go, well, that's a percentage. But if you didn't recognize it and you just went through the motions, this is how it would simplify in the style of a fraction. 67 times 1, there's the percent. This, 100, would simplify it by, like so, as a 5. 11 times 5 is 55%. Right? This one, and this is the only one that you have no choice. You would have to try to simplify it, right? Like so. And then you have that same issue of 375 over 4. It is technically a percent at this point because you multiply by 100. And then you'd have to do it. And ultimately, you would get this. When you have those problems that are unavoidable, right? The hard problem, right? It is worth the time to show a person, I believe, right, the numerous ways to go about the process, because they may not be comfortable looking at it one way, and they might be more comfortable looking at it a different way. As is often the case in math, there's more than one way to get to the answer. Just realize that it's all legal and it really is the same thing disguised. So here's proof with a calculator as the last resort. All right. Let me clear that. All right. If you got to this point, 15 times 100. See where my finger is pointing here. It's sloppy. I'm sorry. And you entered 15 times 100. Brute force top times top. What do you get? 1500 naturally. 16 times 1 would be the other part of it. It's just sloppily written. 16 times 1 is 16. You would end up with 1500 over 16, which if you divided, gives you the same answer. All right? If you simplified it first, and you got, as I had here, 375, it would be 15 times 25. And you'd have 375 over, instead of 16, over 4. All right, divide by 4, you get to the same answer. All right? I'm belaboring the point, and I apologize, but It's important. Okay. I wouldn't otherwise. All right. Okay. Now let's say that you start with a percentage. If you start with a percentage, right, and you're headed either here or here, the process is the same. You're dividing in these cases. If going to percent is multiplying, coming from percent is dividing by 100. So what do we have here to work with? Change 35% to a decimal. All right. If you have 35%, there's a couple of ways to look at this. You could just say to yourself, well, this already means this, all right, and something that's written in the style of what they call a decimal fraction, all right, is a signal that this is really 0.35. That's fine, all right. To do it a little bit more brute force, all right, do it this way. 35 divide by 100, all right? And in this case, because you're dividing by 100, you move the decimal point twice towards the left instead. So where's the decimal in whole number, all right? It would be here, all right? Make waves, all right? Dividing by 100 is scoop this over twice, all right? So you'd end up with 0.35. Okay. This is the more or less brute force way of doing it, and this is sort of a shortcut. All right. Depends on your level of comfort. Never assume that a kid is comfortable. Let's do another, and then I'm going to go back and annotate my diagrams. I feel like I should. All right. Change 69.8% to a decimal. All right. If you went this route to begin with, there's no sin in that, but I don't think it would be a convenience, really. All right. You could reason to yourself, well, if 35 over 100 is 0.35, then this would be 0.698. Right? And that should be the answer, but you might be a little disturbed by that. All right, if instead, perturbed, all right, if instead you went this route, which is to divide by 100, all right, and just remember that you move the decimal point twice to the left when you divide, all right? The effect is to scoot this over to here, all right? In which case you have 0.698. Okay? The next one is a little bit of a nuisance because you're not even given something in the style of a decimal to begin with. Just make sure. What is most important is the actual percent symbol. If you, even though this is like, oh, you go, oh, well, it's a decimal. I mean, oh, well, it's a fraction, right? So I'm just going to convert a fraction to a percentage. It's already a percentage. You have to be leery of that. All right. It's kind of going to throw you, or meant to be throwing you. In this case, you have a percent that you might just want to convert to a fraction only, right? And then convert that to a decimal. This is the train of thought, basically. or if it is possible, go directly rather than sort of indirectly. So if you have a half, I'll put this in blue for the sake of contrast. If you have a 0.5%, right? Start maybe by doing this. Saying to yourself, all right, whatever figure is sitting here, that's there. This is an instruction to divide by 100. Right. You could recognize that this is 0.5 immediately, because we know that a half is 0.5 from considerations earlier. And then you really have this problem. And the effect is to move the decimal point twice to the left when you divide by 100. Right? And then this will just get smaller, so you make 2 extra waves here. And you would get to 0.005 as the answer. If you don't feel comfortable doing that because that seems somewhat suspicious, right, then do it the more brute force way. Right? The only thing is that you have to be also relatively comfortable with division of fractions, which you may be sketchy about. Alright, let me show you this. When you divide fractions, alright, you end up multiplying by the reciprocal. Alright, a neat way to remember this is keep, change, flip. Alright, which means keep the first thing, change this to multiplication, flip this to its reciprocal, 1 over 100. Alright, then what do you have? You have brute force top times top, and you have a 1 up here. Bottom times bottom, and you have a 200 down here. This is because you've done the actual work, which is converting. Dividing by 100, technically you have, because to divide by 100, alright, is to multiply by its reciprocal. Alright. You now have something that is a percentage, that is a decimal number, alright? But it's disguised in the form of something that is purely a fraction. Alright, so what would you have to do in that case? Same thing as earlier, which is convert the fraction to a decimal. Right? They're kind of yucky numbers, right? Because they're large, right? But you can figure it out. 200 doesn't fit into 1. Decimal points line up. 200 doesn't fit into 10. 200 doesn't fit into 100. But 200 fits into 1,000. How many times? Exactly 5, which is 1,000, and it terminates and an extra 0 is unnecessary. And that's the same answer. The bottom line is that there's more than one way to go about this process, right? It really does matter how much information you have memorized to begin with and how comfortable you feel, right? Never circumvent engaging in an act of mental flexibility, right? Because that experience is what makes you smarter, ultimately, not the particular answer, right? Now, because it's worthwhile, let me go back to my diagram and we're going to annotate a little bit. I think it is worthwhile. This needs a refinement. I should have started with this, I suppose. But as long as you do it at some point, you're doing your job. Okay. All right. The fundamentals are true. From either of these to this, you are multiplying by 100. the nuance is what I want to add to the drawing now. All right. When you go from a decimal to a percentage, and you multiply by 100 naturally to do that, all right, remind yourself, I'll put this over here. You move the decimal point twice to the right, which is that direction. Right. When you divide by 100, as you would in the case of going from a percentage to a decimal, and you can squeak this in here, you move the decimal point twice to the left. Okay? Which is that direction, right? This isn't true 100% of the time because you don't always have a denominator of 100, but to get you rolling, all right, when you go from a fraction to a percentage, all right, as long as it's a fraction over 100, all right, the effect is that you're going to cross-cancel the 100s, right, and you just have to attach the percent symbol. You have to remember that when you're going from that style of a fraction to this percentage. If you're dealing with fractions purely, all right, and you're going from a percentage to fraction, all right, again, you're still dividing by 100. Write it like this instead. So you'd have something over 100. Right. Let's get back to our examples. Just here. Alright, now look at problem 4. This is a word problem, so we may have to dissect this via the means we have established in earlier classes. Let me reinforce. Alright, according to the U.S. Department of Agriculture in 2014, the United States produced about 264 million pounds of cherries. Interesting. Alright, of these cherries, 182 million pounds were produced in Michigan, 36 were produced in Utah, 26 were produced in Washington, 20 million were produced in other states. Determine the percent of cherries produced in each of the following. Alright, the Michigan one, let's just add some distinction here. I'm going to put these in a similar color. Alright, in reference to their numbers. Utah, it will make blue here. And 26 is Washington. And 20 million were other states. Okay. Determine the percent of cherries produced in each of these. All right. The way this is going to work is that they are percent of the whole. All right. Here's a model. Right. This is essentially what we're looking for. What percent of the whole or total amount are each of these individually? As they've described. All right. Remember this: you have a part or a portion over the whole, or the total, or another way of referring to this is the base. Right? That will establish essentially a fraction. Well, what do they want? The percent. So what we're going to have to do eventually is we're going to have to convert our fraction to a percentage, right? Which means what? When you convert from a fraction to a percentage, you're multiplying by 100. But we need to get this fraction first. Right? In the case of, let's see, Michigan, I'll just call it Mitch. It would be 182 mil over 264 mil. In the case of Utah, it would be 36 over 264. In the case of Washington, it would be 26 over 264. I should have put that in green, sorry. Consistency, not good. Green is a little hard to see, unfortunately, in this setting. All right. And then other states is 20, right? 20 out of 264. Now I want you to see something. They're talking about something in the magnitude of 1 million, right? So I abbreviated even the word million here because I'm being lazy, all right? What would happen if you had put in the extra zeros, all right? There would be 6, right? Because that's up to 100,000, and then this would be 2 million, 82 million, 182 million, all right, as described verbally, more verbally. But even if I went back to the original figure and I filled in those zeros as is necessary, look what would happen, all right? You would have something in the magnitude of 1 million sitting on top of something in the magnitude of 1 million. So even if you went via the shortcut to simplify these two, right, the effect would be that all of these zeros would cancel. Remember, pairs of zeros you could cross out as long as they're one above the other somehow, right? That means that the relationship between this enormous number here and this enormous number here is exactly the same as a dumbed down version of it that's just this long, 182 over 264, all right? I'm mentioning it because I don't want you to worry about it. I just want you to train yourself to look for shortcuts like that. Even if you spelled out mil over mil, it's something over itself. And we've already established earlier on this semester that something divided by itself, as this would imply, cancels, even if it's words. All right? All right, so it's 182 over 264, 36 over 264, 26 over 264, and 20 over 264. All right? Now, what does the process entail converting from these fractions to these percentages? The minutia would be basically this, the fine details. It would be this disgusting figure here times 100. All right, and similarly, this 36 over 264 times 100. And this 26 over 264 times 100. And this 20 over 264 times 100, right? Have you noticed that the tedium of this is on purpose, right? Why? Because if you repeat something, it's more likely that well, obviously there's a pattern then, right? But a person will notice that. They'll go, oh, well, this is the same process again and again. So at this point, that really has happened, but I kind of fudged it earlier because of that one minor mistake, right? So, anyhow, there's a strategy to this, and it entails, again, taking that portion, writing it over the whole, and then converting that ugly fraction to a percentage via times 100. All right? Can you whittle this down? Yeah, that's an even number, and that's an even number. Go ahead. All right? Same thing here, same thing here, same thing here. But maybe spare yourself a little bit of trouble. All right? At this point, because we're not going to reinvent the wheel, have your calculator convert this top, divide by the bottom, and then multiply by 100. Convert this to essentially a decimal first, and then to a percentage, because it's easy. All right, top divide by bottom times 100, top divide by bottom times 100. All right. Let's see what the effects are. If you take a calculator and you start with this one, 182 over 264, you would enter 182 divided by 264. That is the process of converting a fraction to a decimal via the top divided by the bottom. And now you have this decimal, all right? But in order to convert a decimal to a percentage, what do you end up doing when you actually complete the thought of multiplying by 100? The effect is that the decimal point scoots over 2 spaces. So you may just know that even without your calculator, but here's the proof. Oh boy, I'm writing it backwards. Sorry. 68.9, right? What it actually is, to be very precise, or very exact, I should say, is this. In the case of Michigan, it's 68.93 repeating percent. All right. If they ask you to round that, they would have to specify a particular location, the ones place, the 10th place, or so forth. All right, but this is the exact answer. 68.93, a bar sitting over both digits that repeat. To abbreviate. All right. In this case, it would be 36 divided by 264. And you'd end up with this, similarly repeating. 0.136, 363636 times 100 is really 13.63636363. All right. So $13.63 exact. Bar over the 6 and the 3. All right, or round if they specify to what. Don't go to sleep. You guys either. All right. 26 over 264. All right. Top divided by bottom, 0.0984848484. All right, times 100 is 2 decimal places. So 9.848484. Utah, Washington, 9.84% repeating. All right. And then other is 20 divided by 264. 0.0757575 times 100, 7.575757, and so forth. Okay. 68.93% repeating, 13.63% repeating, 9.84% repeating, 7.57 repeating. Okay. Moving on. All right. Let's take a look at. Let's get 5 for it. Let's take a look at this. This sheet here, formulas. All right. And again, I'll annotate whatever is necessary. All right. When we discuss percent of change or percent markup or markdown, A couple of things. A slightly slimmed down, simplified version of either of these, as you can see, they involve the same operations, really. Subtraction, division, multiplication of 100. Subtraction, division, multiplication of 100. They're really two different incarnations of the same formula. You might generalize as this. Percent up or down is equal to new minus old over old times 100%. Or if it's easier, it's a difference. Right. You have to be careful about how you arrange these two things, because sometimes the new amount that is quoted to you is smaller than the original amount, which means that you'll get a negative, and that's important because that signifies something is going down. You're going to get a negative as an answer. All right. When you get a negative, outcome here, this implies something went down, a decrease. Now, when you're just talking about percent changes, this is the way the book chose to generalize. An amount in the last period of time, right? An amount in the previous period of time. Old is how I'm choosing to talk about the exact same thing. New, right? Or original, right? And final, if you like. When you're talking about markup, right? Markup is an amount of money. Remember, is an amount, it's usually a dollar amount, added to the cost, right, in order to turn a profit. Right? In other words, a store will sell an item for slightly more than they paid for it. Right? That's a markup. All right. That's why when you purchase things like a calculator, you can get this calculator pretty much anywhere, right? You can get this at the school bookstore, you can get this at ShopRite, you can get this at Staples or Walmart or Office Max or what have you, right? Or online. Why is it that the same item costs different things in different places? Because they've applied different markup to their profit margin. Right? So, when you're asking about the percent markup, you're, rather than looking for an exact dollar value as the amount, you're instead looking for the percentage in respect of the original cost of something. Right? So it's the same thing. The new price, if you will, minus the old cost over the old cost. Right? The cost is usually the manufacturer or whatever warehouse that they got the item from, right? The selling price is what is on the shelf at the store, okay? Anyhow, it's new minus old divided by old times 100, right? And you get a percentage as an answer. Notice what these are. Because of this line here, what is this? This is a fraction, to be more math general, and this is a fraction, right? And if you're going to convert it to a percentage, how do you do that? All right. When you're converting from a fraction, which you've created by putting something on top of something else, a ratio to be more exact, you're multiplying by 100. All right. So, you have all the information, and it is, in fact, staring you in the face. So let's do some examples to illustrate. All right. Let's see. Cherries. I skipped 5. I don't remember what the reason was, but this is more interesting, I think. There's my thing. There we go. Anyway, push a dot. Yeah. Alright. There you go. Okay. We have a general formula here. New minus old over old. It's not the most eloquent way of speaking about it, of course, but it does get the point across. Alright, so let's engage here. On May 13th, the price of one share of McDonald's stock was $103.53. Later, on October 16th, the price of one share of McDonald's stock had fallen. This is already signifying that there's a decrease. So that means that you should get a negative outcome, right? To $89.91, right? Determine the percent change in the price of a share of McDonald's stock during this period. All right, so percent change, they're not specifying, even though it's going to be a percent decrease. In reality, it's implied. Is going to be some new amount minus some old amount divided by an old amount, an original, whatever you like to call it, times 100. So, what's the original? 103.53, which you would have to write in two different places. What's the new amount? $89.91. Notice that because there's no commutative property of subtraction, right? This order is very important. You have a smaller thing written in front of something that is a larger magnitude. And the result of that is that you're going to get a negative as a result of this. Do this with your calculator, because we're not really trying to reinvent the wheel right now. And it would look something like this. 89.91. Sorry for the glare. Minus 103. I miffed it, didn't I? Yep. $103.53. And now you hit enter. You see that you get a negative difference of 13.62, is it? I'm reading it backwards, right? And then you hit divide by 103.53. And you get this. And I'm very suspicious. Oh. Here's another problem with teaching. When you're reading something backwards, as I am, I pressed the wrong button here. So I'm going to go back to this and take advantage of my arrow keys and put the correct operation here. Now hit enter. And there you have it. It's negative 13.16, pardon me, 13.62. Negative, as to be expected from a decrease, 13.62%. Alright. Essentially, the stock had fallen over the course of, what is that, June, July, August, September, October, 5 months, 13.6%, roughly. Oh, I'm reading it backwards. Damn it. I'm sorry. I don't read things backwards. $13.2, I'm sorry. Negative 13.12. Doing too many things at once here. 89.11 minus 103.53 divided by 103.53 times 100. I'm sorry, I'm reading stuff backwards. Okay, it should be this. Negative 13.15, not 2. It looks like a 2 from my perspective because my camera is backwards. Okay, so sorry. 1, 5, and there's some change here. So if you rounded this, and they really should specify, if they don't tell you, right, which place to round to at this point when it is a percentage, even if it is a decimal percentage, I would round it to the whole number. So you might just say that this is about down 13%. All right, let's see what the textbook had done. They might have just done negative 13.2%. That is within the realm of accuracy. Okay. There you go. Yeah, they rounded to the tenths place, but they just decided on their own that that was fine, right? It repeats, as you can see. It's 0.1316, and then, well, there's not a pattern, but there's something. At least not at that point. Okay. So negative 13.2% down. All right. Let's take a look at 7 here. All right. What is this? This is a 2-parter here. Oh, it's light. Okay. Haldren Hardware Stores pays $48.76 for glass fireplace screens. Okay. They regularly sell them for $79.88. So as you can see immediately from what they paid and what they charge, there's a markup. Right? It's not too much, but at a sale they sell the item for $69.99. Right? So then they're now that is quite a lot. I'm sorry, going from 48 to 79. Yuck. All right. Determine the percent markup on the regular price. All right. So to answer A, what numbers do we need to involve? What they paid and what their regular item is. Okay. So the percent would be, again, equal to the new minus the old over the old times 100. All right, which means essentially 79.88 here minus 48.76 here divided by 48.76. Do these first. Straighten that out. Use a calculator times 100. All right, what would you get? I'm going to look right at it rather than read it backwards. 79.88 minus 48.76. You'd get $31 and looks like 12 cents. Yep. It's positive because the new amount is larger. And then you would divide by 48.76 and you would get this. All right. 0.63822, whatever it is. All right, you could already predict that multiplying by 100 is going to make this 63.8. All right, so this is going to be about equal to 63.8%, and that's rounded. Okay? And that's a markup because it's positive. So this is a mark up, all right, rather than a mark down. All right? Percent. The second question or portion of this is that the percent markup on the sale price. So we're still going to need to use this, but we're going to use this figure instead. All right, so percent would be equal to, again, the new amount minus the old amount over the old amount. Do that first, times 100. All right, and input these values. 69.99 minus 48.76 divided by 48.76. One advantage of working with markers is that you can superimpose what you need to, like I have. Alright, so clear. 69.99 minus 48.76 divided by 48.76. And you see that you get, when all is said and done, 48.76 looks like. Yeah, that sums up here. Let me just double check. Working in the dark doesn't help here. 69.99 minus 48.76. Right. You get this. Right. Divided by 48.76. Yeah, I must have put something incorrectly. Times 100. And then you have this 43, all right, 0.5, all right, if you round it. This, because it is still a positive, is considered a markup. In the style of a percentage rather than just the dollar value. Okay. Alright, here's a markdown problem. To help get rid of its remaining 2016 calendars, Cardin's Pharmacy reduces the price to $4. If Cardin's cost per calendar was $5, determine the percent marked down on the calendars. Okay, so here's our formula. We could maybe finagle this a little bit. And in this case, I might just refer back to our percent equations to spare us some trouble. We'll see. All right. Let's figure out what goes here, here, and here. All right, in respect of the formula. It was $5, so I would call that the old amount, in which case you're going to divide by 5 and subtract 5. The new amount is 4, so we would put that here in respect of minus, subtraction symbol. All right. What is the difference of 4 and 5? $1. If you have essentially 1 over 5, these zeros are superfluous. And then you have 1 over 5 times 100%. Alright? So you could disguise this without involving a calculator fairly easily, right? Put a 1 under here. Cross simplify if you recognize that 5 and 100 are divisible, and they are. 5 is made of 5, that may sound silly, but it's true. 100 is made of 5. So you can simplify that as you can really divide them before you multiply them. So this becomes a 1 and this becomes a 20. Which means that this is a 20% markdown. Okay? Downtown. Okay. One thing I neglected, all right, is if you have 4 minus 5, this is a negative, right? From integers, right? Which means that this is a negative 1/5, and therefore this is a negative outcome of 20%. Okay. Here's an example of a down payment. This is a problem that you may attempt to rephrase. You don't have to accept things exactly as they are. All right? Within a realm of logic, right? Within boundaries, all right, you could take the problem if it's not written clearly and rephrase it. So let's see what we have here. Melissa wishes to buy a condominium home for $189,000. Right? To obtain the mortgage loan, she must pay 20% of the selling price. So 20% of this, of $189 as a down payment. Right? This is my rephrasing of this problem. 20% of 189,000 is what? Down payment. A couple of things to remember from percent equations. Right? This is an older conversation at this point. Remember some key phrases, right? Right? Of is times, at least to start with, every single time. Right? And is equals. Right? So if you could take the information and just refine it, right, you realize that this is a part equation out of the 3. Right, so, and you could already see what the effect is, but let me just do this. Of is times, is equal. This is sitting here already, so let's just rewrite 189,000. And then you have the option, when it comes to 20%, you could either write this in the style of a decimal if you feel more comfortable to use it, or you could write this in the style of a fraction if you feel more comfortable. My thinking is this: if you're dealing with loans, and loans involve usually round amounts of money, rather than very, very specific amounts of money, like what in other words, like so much dollars and then change on top of it. All right. Then when you're converting the percentage to something that is usable for the sake of actually multiplying, make it a fraction, all right? Because if it's 20%, what's the denominator going to be automatically? 100. And therefore, that would be a little bit easier to simplify, all right? You already have a 1 sitting up in the front here, and then 2 zeros that trails it. Then you have a diagonal to this. You have a figure that, again, is a round number that has zeros in it, all right? What that means is that if you cross simplify strategically, right, which is really dividing, you can cross out 2 zeros here and 2 zeros here. The denominators that are left over are just 1, which are superfluous. You don't have to write them. And realistically, what you have to do is multiply 20 times 1,890. All right. If you were doing this by hand, right, you can kind of cheat by going, I'm going to distribute 2 to each of these things, and then just tack a 0 on the end of it. All right, it's a mental math shortcut. 0 times 2 is 0. All right, 2 times 9 is 18. Carry the 1. 2 times 8 is 16 plus 1 is 17. Carry the 1. 2 times 1 is 2 plus 1 is 3. With that extra 0, it's 37,800 is what it should be. All right. Alternatively, if you use a calculator, probably the easiest thing to do is just use a decimal in that case, because the calculator is you know, right out of the box prepared for that. All right. Just know that 20%, if you divide it by 100, is 0.2, all right, with a 0 attached to it. So then it would be 0.2 times the original figure. 0.2 times 189,000. You'd have this equals 37,800 as predicted, right? All right. One, well, let's see. Look at 10. And then let's see if it's worth doing this. These are percent equations, so I think this is worthy of discussion again. What I want you to do, again, I already sort of broached the subject a couple of classes ago, I think. That's a lot of mess. Erase this. Try to get yourself to recognize key phrases. When you're working with these types of percent problems, all right? If you say is what or what is, it's probably a part equation, and it would be something like this, right? It would be regular arithmetic, either times the decimal or times a fraction, whichever is your preference. When you're looking for an original amount of something, or the actual percent itself, right? Look for these phrases. Of what usually signifies that you're dealing with this, right? You'll start out writing it in a similar manner to this example here, right? But because what you're looking for is more or less in the middle of the equation, you end up having to use algebra in a case like this, which basically means you're going to divide at some point. Literal percent equations, right? You end up having to do division as well, but there's the added step of converting to a percentage. So after you've done your division, you're essentially going to have to multiply by 100. All right. So this is purely arithmetic, and these two are algebra. When you're looking for a percent, that's the one that's the most involved. Okay. And don't be afraid to sort of rephrase what's given to you, but sometimes it's just gobbledygook. Okay. So let's take a look at this. All right. The U.S. Chess Federation, USCF, has about 77,000 members. Again, get in the habit of circling these figures. Of these members, 28,000 are considered scholastic members, meaning they are attending some level of school from kindergarten through college. Okay. What percent of USCF members are scholastic members? Let's rephrase this. What percent of USCF is scholastic? Right, that's a very slimmed down version of the original question, but so be it. The figure that they quote of USCF members is 77,000, so that would be appropriately superimposed here. And scholastic is 28,000, so you would put that here. Essentially, what percent, let's just use the letter P for percent, of is times 77,000 is equals 28,000. If you have an expression that in slightly better etiquette would have the number sitting in front, it doesn't really matter if you put it in the front or the back, really. But if you do, it would be, again, better etiquette, pinky in the ear, sipping tea. It would look something like this. All right? You have something times the thing you're actually looking for, namely the percentage. Because the thing that you're looking for is not alone, one would have to engage in algebra, which is to perform the opposite operation. What is the opposite of multiplying? Dividing, which in math world we have a tendency to write like so. This is dividing. And if you did it here, what makes it legal, again, you can get away with murder in math as long as you're consistent. Whatever you do here, you're obligated to do here. It balances. Right? That's the beauty of it. Something, even something ugly, divided by itself strategically diminishes to 1. That leaves you with the p%. And then you notice that you have an ugly fraction, right? You have 28,000 over 77,000. You could enter this into your calculator, make it do all of the brute force work. No sin in that, really. But you could sort of set it up easier on yourself. Less typing, right? These zeros will cancel because they have the same relationship as just this over this. Right? You might also recognize these figures, 28 and 77, if you know your multiplication tables, right? Which is another reason why it's good to memorize them. They're both divisible by 7. They're both made of the number 7, right? Which means that it's probably the GCF, but I haven't verified that. 28 divided by 7, again, consistency. Whatever you do to the bottom, do to the top. Whatever you do to the left or the right. That's what makes it legal. All right, 28 divided by 7 is 4. 77 divided by 7 is 11. That's a simplified fraction. The relationship of this to this, is the same as that to that, and that to that. Right? It's just easier figures to work with. All right. Anyhow, this is evidently a fraction, and what we have to convert to is a percentage. So what do we have to do when we engage in that process? Fractions to percentages times 100. So you multiply by 100. Disguise 100 as a fraction itself. Check to cross simplify, you can't in this case. Brute force top times top is 400. Brute force bottom times bottom is 11. This is now a percentage, it's just ugly. Now you divide the top by the bottom. Whether you do so with the calculator or you do it by hand. I'm going to try to make up for my sins before, so I'm going to do this brute force. Alright, hopefully I won't flub it. Alright. 11 goes into 40. You have to be willing, incidentally, as a teacher, to make a mistake in front of your students. Why? Because you're not God, alright? And you have to make sure that they know that, alright? It's nice to be revered, right? But it's not important. It's, you are just a vessel for information, alright? 11 for 40 is, 11 into 40 is 3, right? Which is 33. And the difference is 7, and you drag down to 0. 11 goes into 70, 60, 6 times, which would be 66. And the difference is 4. And this is going to repeat, right? Because if you had 40 to begin with, it's going to be 3 again, and then 6 again, and then 3 again, and then 6 again. All right. Anyhow, this is now a percentage. All right. That is probably easier to give to a person, and they'll understand it and appreciate it. All right. 36.36 repeating percent, if you want to be ultra accurate here. All right. You could round it if you'd like to just 36%, but they really should specify, what place you'd like to round it to. Right? That's kind of debatable. Right? Like notice here, the textbook had rounded it to the 10th place. Right? Why? Because if it's a 6 in the hundredths, you would change that to a 4. Okay. One more of these and we'll stop. The population of Germany, und ja, okay. About, looks like 10 million, let me clean this up first because it's messy. $10,400,000, or about 13% of Germany's population, is younger than 15 years old. What is the approximate population of Germany? All right. This is a base equation without it really specifying. Right? Let me show you why. Here's percent equations, again, as a reference from a couple of classes ago. All right. The way that I think this is going to rephrase is going to be of what? All right. Which means that, again, it's going to entail using algebra, so therefore opposite operations, but I gotta refine it so that it's a little less ugly and a little less vague, right, from what's given, right? So let's take a look at that, right? If the question is, what is the approximate population of Germany, and that would be the total, basically, or the whole, and therefore that would be implied as a base, right? Then the way that I could write this is as follows. The percent that's quoted and the amount of people that are quoted. Yes, this is in reference to people who are 15 and younger, right? 13% of what is that figure? The 15 and younger crowd demographic. 10,400,000. This is a slimmed down version of this question, right? And I think it's a little bit more understandable as such. Okay? So, of the total, if you like, instead, of the whole, if you like, instead, of the base. Right? Of is times, is equals. Right? The question is in the middle of the equation. So therefore, use some letter to represent that. Right? I'm just going to go with B for base. All right. 13%, in order to make it usable, this is good for presentation, right? People like when you talk about statistics in the news or whatever, they'll say a percentage to you, right? But when you're actually doing the arithmetic involved, you're either going to make this, again, a fraction, or you're going to make it a decimal. So do what is intuitive to you, right? I would bet, if you're going to use your calculator, that the decimal incarnation of this would be easiest. So from a decimal, from a percent to either of these forms is to divide by 100. So if you either write it as 13 over 100 or you write it as 0.13, right, that's fine. Probably, again, as a calculator, you would have 0.13 times B is equal to 10,400,000 people. That demographic. Okay. Again, this is in the middle. The thing that we're looking for is essentially in the middle of the equation. So we engage in algebra. The opposite of multiplying, I'm just using a dot in this case, is to divide. That is to move from here to here over equals. You do the opposite. Divide by 0.13. This cancels. Divide by 0.13. Right? And you would enter those figures. Expect a number that's going to be larger than what you're given, even though it's a pretty big figure to begin with. Why? Because the whole would normally be larger than the part. Alright, so typed, or entered, you'd see this. Alright, 104, and then 5 zeros to follow it. 10,400,000. Divide by the decimal, which is point, what is it, 13? 13. And you're going to see this. Looks like 80 million. Alright? So very good. Alright, this ends up being 80 million. Sadly, the calculator doesn't seem to separate them out to make it easier to read, but there'd be a comma here and a comma here, at least in the way that we do it in the United States. Alright? 80 million people is the answer. Okay? Alright, that's that. Alright, so let me turn this off. I'll just remind you of a couple of things. This thing's get so dirty. Now at this point, because we're finishing up the second week of the semester, for homework, you definitely want to have your MyLab established. And if you haven't done that yet, please get on top of that because you have a slew of assignments already. What is currently due would be section 10.1 in MyLab. Now if you notice, on the calendar, the way that I have it here is that I've scheduled a test. all right? I'm gonna more or less give this to you as a freebie, all right? Because I really want you to have the experience of doing this work, all right? I'm gonna shoot a video on Tuesday, all right, explaining the solutions to this, but you don't have to actually submit anything. I'm just gonna give you credit for it, all right? Make sure that you do your homework, right? When the final rolls around, right, the final is gonna be provided by the department. I can't give you that as a freebie, all right? But for this test at least, all right, I will, okay? So just make sure that you get your MyLab self in order, all right? And then on Monday, pardon me, on Tuesday, I'll mail test number 1, right? And shoot the video discussing it. All right, don't worry about it, just do your homework and everything will be fair and square. Okay? All right, thank you for sticking with me and I'll see you again on Tuesday. There's no extra video this week. Be careful.